So in this episode on stoichiometry, I want you to be calm. You have to take your time to understand a whole lot of things. And that's why I'm breaking it down into series so that we take it step by step. Now, based on those formulas I gave you in the last class, we're going to be using them to solve questions in this class. And in the next class, we're going to be treating limiting and excess reagents, which is the aspect where major problem is in dealing with stoichiometry. So now let's solve these questions using those formulas one after the other. You will see how to apply those formulas and you see that it is not actually that difficult. Just calm yourself down and make sure you follow the steps through. So now, whenever you are asked to do something in stoichiometry, probably they ask you to calculate mass. Your brain would have thought about number of mole is equal to mass over molar mass, right? So the next thing is, how do I get number of mole? Now, this is where chemical equation comes into play. Sometimes you need to use your known to calculate what we call the what? The unknown. So we're going to be doing that in this episode. So now, by the time I give you a question to calculate something, your brain should think about that thing that I asked you to calculate. Then how do you get there? So first thing is that, where am I going and how do I get there? Calculate mass. Number of mole is mass over molar mass. So I'm going to calculate mass. That's where I'm going. The formula we use is number of mole is equal to mass over molar mass. Even if it involves series of equations, it is still these formulas we're going to be applying. So let's pick the questions one after the other and see how we can solve all of these problems. So the first question, I'm going to solve these 5 questions with you, and you're going to be solving the next 5 or so in the next slide. So now, the questions here says that how many grams of water would be formed if 0.4 grams of hydrogen reacts with enough quantity of oxygen? How many grams of water would be formed? Now, you would have seen that the question says that how many grams of water? What are you asked to calculate? Mass, definitely. So that means you're going to be using what formula? You already know where you are going. Number of mole is equal to mass over molar mass. So that's the first thing. So you're now going to write number of mole of water is equal to mass of water. That is what you want to calculate over the molar mass of water. Now, from the last episodes that we've been doing, we actually learned how to calculate molar mass. So how do you calculate molar mass of water? You already know. You have 2 hydrogen and you have 1 oxygen. So that is going to be 2 into 1 plus 16. And that is going to be 18 grams per mole for the molar mass. So now you know the molar mass. What's the next thing? You want to calculate mass. So the next question you will ask yourself, how do I get number of mole? Is that taken? So now, to get the number of mole, were you given? No, you were not. You were given the mass of hydrogen. So what do you think we're going to do? We're going to use that mass of hydrogen from the balanced equation to get the number of mole of hydrogen, then compare the mole ratio and get the number of mole of water from there. And you slot it into your equation, and that's all. So let's look at what I'm saying. So how many grams of water will be formed if 0.4 gram of hydrogen reacts with enough quantity of oxygen? So what do you have? Hydrogen reacting with enough quantity of oxygen to give water. I told you how to balance equation the last time by inspection and by simultaneous. This is a simple equation, so whenever you have single elements on its own, they are always easier to balance. So how many hydrogen, how many oxygen? So if I have 2 here, my oxygen is balanced, then I can have 2 here. So if you look at what I have here, I have 4 hydrogen here, 2 oxygen atom, 4 hydrogen here, and 2 oxygen. So the equation is balanced. So you can now say this is 2:1 to 2. So the balanced equation shows 2:1 to 2. So what does that mean? Now, if this one is 10, then this will be 5, then this will be 10. So meaning that I can know the number of mole of water even if I know any of these guys. So this is my known now because I'm given mass of hydrogen. So I can calculate the number of mole of hydrogen from here. So now, when I will say that number of mole of hydrogen will be equal to mass of hydrogen over molar mass of hydrogen. I hope you're following. So what is the mass of hydrogen? That's 0.4 gram divided by molar mass of hydrogen. That's 2. And that should be like 0.2 mole. So let's check that out. So that's 0.4 divided by 2. That's 0.2 mole. So now that you have 0.2 mole as the number of mole of hydrogen, what do you think number of mole of water will be? Their ratio is the same, 2 to 2. So if this is 0.2 for hydrogen, it is going to be 0.1 for oxygen, and it is still going to be 0.2 because the ratio is 2 to 1 to 2. Do you get that? So you use the number of mole of the one you know to calculate the one you do not know. So the question is, how do I get there? I want to calculate mass. Then I'll use number of mole is equal to mass over molar mass. Now I know molar mass, which is this. How do I get my number of mole? So my number of mole can be gotten from a balanced chemical equation. And you will always be supplied some other things to calculate the number of moles. So we'll solve series of questions. So now, can we calculate the mass of water now? So from here, mass of water is going to be equal to the number of mole of water, which is 0.2 times mass of, that is 18. So 2 times, that's 36. So the answer should be 3.6 grams. So that's 3.6 grams. So the mass of water produced from reacting 2 moles of hydrogen, 1 mole of oxygen is 3.6 grams. So let's look at the next question. Please, do you understand this? Go through it again. It's very simple. We are using our formula and we are trying to get our number of mole from the balanced equation. And that's all. So the next question says that, so one of the things you need to know in this case is how to balance equation. So the next question says, calculate the volume of nitrogen that will be produced at STP. The moment you add that, volume of nitrogen that will be produced at STP. So which formula are you going to apply? The question says volume of nitrogen at STP. So that means we are using number of mole is equal to volume at STP over molar volume. That was the one I gave you last. So now you are using number of mole is equal to volume at STP over molar volume. So you need to know number of mole and molar volume. Molar volume is 22.4 dmq. So now do I get number of mole? Again, from the balanced equation. So let's read the question. Calculate the volume of nitrogen that will be produced at STP from the decomposition of, you are given mass of ammonium dioxonitrate 3. Now that you know the mass of ammonium dioxonitrate 3, you can balance the equation. Now, don't bother yourself if you don't really know how to balance some equations yet. When you treat metals and non-metals, all of this will be clear to you. One of the ways we prepare nitrogen is by breaking down ammonium dioxonitrate 3. If you want to prepare N2O, then it will be trioxonitrate 5. So all of these things you will learn under metals and non-metals. So now, but let's look at this. Ammonium dioxonitrate 3 is NH4NO2. That is ammonium dioxonitrate 3. Then when you split this compound, it will give you nitrogen gas and water. So now let's balance the equation. I have 4 hydrogen here, then I can have 2 here. So my hydrogen is 4. How about oxygen? Oxygen is 2. That's balanced. Nitrogen is also 2. So that's balanced. So their ratio of combining is 1 to 1 to 2. Can you see that? Now that you know the balanced equation, whatever the number of mole of this is, I can know the number of mole of nitrogen. Now I'm trying to calculate volume of nitrogen. So I need to know the number of mole of nitrogen. That's what this part is talking about. So now, how do I get the number of mole of ammonium dioxonitrate 3? So since I'm given mass, so I will say the number of mole of ammonium dioxonitrate 3 will be mass over molar mass. And let's calculate the molar mass. So the molar mass is going to be, I have 2 nitrogen, I have 4 hydrogen, and I have 2 plus 2 oxygen. So that will give me 2 into 14 plus 4 into 1 plus 2 into 16. And that will be 32, 28. So that will now be 28 plus 4 plus 32. That's 64. So the molar mass of ammonium dioxonitrate is 64 grams per mole. So now that I know the molar mass, then I have the mass. The mass is 9.6 all over 64. So what would that give me? So I can have 9.6 divided by 64. And that's 0.15. 0.15. So now, what do you think? If the number of mole of ammonium dioxynitrate 3 is 0.15, what do you think the number of mole of nitrogen will be? Very good. Since their ratio is what? 1 to 1. Then if this is 0.15, this will be 0.15. What do you think this would be? 0.30. That's 2 to 1 to 1. That's how it is. So now, number of mole of nitrogen is determined to also be, since their mole ratio, number of mole of nitrogen ratio number of mole of ammonium dioxynitrate 5, dioxynitrate 3 is the same, is 1:1. So that means that the number of mole will be equal. So from there, I can now say that the volume of nitrogen at STP will be equal to number of mole of nitrogen multiplied by molar volume. And the number of mole of nitrogen is 0.15, is the same as that of ammonium dioxynitrate 3. Pardon. So the molar volume is going to be 22.4. So that will now be 0.15 times 22. That's 3.36 cm. Depending on your options, though, you can have your answer in cm cube or dm cube. If your option is in cm cube, then you multiply with 22,400. So this is how to do it. First is know where you are going. The question says calculate volume at STP. Then your brain should think about number of mole is equal to volume at STP over molar volume. Second is how will I get there? That means I need to know the number of mole. That's the next thing. So then how will I know number of mole? From what you are supplied, you are given mass of ammonium dioxynitrate 3. And you know that if you balance this equation, a balanced chemical equation can tell you a whole lot of things. So now that you balance the equation, you can say that if this is 1 mole to 2 mole, then this is going to be 0.15, and this is also going to be 0.15. And that's all. Can you pause and try the next question? How much of magnesium is required to react completely with 100 cm cube of 0.1 mole per dm cube HCl? You have to calculate mass of magnesium. Can you try that using my explanation? So I believe you must have paused and tried and see if you can get it. You have to practice. That's one of the ways to get it. There are shortcuts to solving these questions. I will solve them again when a new video. I will only use the shortcuts and you see how to solve them. But I just want you to get these principles right first before you start applying shortcuts. So now, how much of magnesium? You have to calculate the mass of magnesium. So to calculate mass of magnesium, that means you are going to use number of mole is equal to mass over molar mass, right? So now I need to know number of mole. So how do I determine number of mole? You are given something, that of HCl, volume of HCl and concentration of HCl. So that means that magnesium, so let's start from here. Magnesium will react with HCl to give me magnesium chloride. This is one of the reactions you will learn if you have done acid, base, and salt. A metal will displace hydrogen from acid. So plus H2. Not all metals though, highly electropositive metals. So now, this is what you have. That's a balanced equation. 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine, 1 magnesium. So their ratio is 1 to 2 to 1 to 1. So whatever HCl is, half of it is what magnesium would be, since they are 1 to 2 to 1 to 1. You get? So now I want to calculate mass of magnesium. I already know the molar mass of magnesium. So I want to get the number of mole of magnesium. That's the next thing. So how do I get the number of mole of magnesium? I will get that from the number of mole of HCl. HCl is my known. So number of mole of HCl is going to be concentration of HCl multiplied by volume of HCl. Since the volume was given in cm cube, we divide by 1000. And concentration of HCl is 0.1 times volume 100 divided by 1000. This and this will go. This is going to be 0.01 mole. So the number of mole of HCl is 0.01 mole. So now if HCl is 0.01, what do you think this would be? It has to be half of this. So that would be 0.005. So that's 0.01 divided by 2. That's 0.005. So that's 0.005 mole. So now that, do you understand this? The ratio is 1 to 2. So whatever this one is twice, this one must be half of it. If this is 10, this will be 5, right? If this is 20, this will be 10, right? So if we got this to be 0.01, then this will be 0. Just divide this by 2. That will be 0.005. Here you get. So now that you have the number of mole of magnesium, you can determine the mass of magnesium. So number of mole of magnesium is equal to mass of magnesium over the molar mass of magnesium. So mass of magnesium is going to be that number of mole times the molar mass. And number of mole is 0.005 times 24. So that would be 0.005 times 4. So the answer is 0.12 grams. Here you get. So the mass of magnesium that reacted with HCl. So where are we going? Calculate mass. How do I get there? I need to know number of mole. From where? From HCl that was given. It's as simple as that. Just always compare them. So let's solve the last one, this number 4. I'll give you your own series of questions to solve now. You can always pause to solve it first and see if you get it right. And if you miss it, at least you know you tried. You go again. So number of mole of hydrogen ions in 9.8 grams of tetrasulfate 6 acid. So if they ask you to calculate number of ions, what formula are you applying? Number of mole is equal to number of particles over what? Avogadro's constant. So to calculate number of ions, my number of mole will be number of particles, which can be ions, atoms, molecules, or whatever, over Avogadro's constant. So my number of ions is now going to be number of mole times Avogadro's constant. And you know Avogadro's constant. So the next thing is, how do I get number of mole? You are asked hydrogen ion, but you are given mass of A2SO4. When you have A2SO4, A2SO4 will split to give you 2 hydrogen ion plus SO4 2 minus. You will get to know all of these things very well. Just keep on with it for now. Not everything you just know suddenly, step by step. So now, if this one balances like that, means if this is 1, this is going to be 2, and this is going to be 1. So how do I know the number of mole of hydrogen here? Number of mole. I want to calculate the number of ions. So if I have 2 moles, you remember 1 mole of a substance contains the Avogadro's number. So how many? I now have 2 moles then. So, but let's get the number of mole from that of A2SO4. So now, number of mole of A2SO4 is going to be mass of A2SO4 over molar mass of A2SO4. And the mass of A2SO4 is 9.8. Divided molar mass of A2SO4, if you calculate, that's going to be 98 divided by, so that would be 0.1 mole. If you have solved questions, there are some things you will get used to normally, or if you have practiced. So if this is 0.1 mole, my dear, what would this be? My dear. So that's 0.2. You know, you're just going to multiply this by 2, because if this is 5, this will be 10. If this is 10, this will be 20. If this is 20, this will be 40. That's what the mole ratio just means. It tells you a whole lot of things. So if this is 0.1, so you just say 0.1 times 2, and that will give you 0.2 mole. So now you know the number of mole of the hydrogen now to be 0.2. So the number of ions is now going to be 0.2 times 6.02 10 raised to the power 23. And so like this, minus 1 can go here. So you can now say, let's write it down here. So the number of ions, so you can do this. So that would be 2 times this would be 12.04. So times 10 raised to the power 23 minus 1. So that would be 12.04 times 10 raised to the power 22. So this is the number of ions that is present in 0.2 mole of hydrogen ions. So that's what you have. Now, please get this right. It's simple. You already know your formula. Number of particles over Avogadro's constant. How do you know number of mole? You know it from what you are supplied. And that's that. So the last one says that a balanced chemical equation is based on the law of what? A balanced chemical equation is based on the law of conservation of mass. The total mass you have on the left hand side will be equal to the total mass you have on the right hand side. for a balanced chemical equation. Let me show you what that means. For example, you remember the Haber process. When nitrogen reacts with hydrogen to give ammonia, if you balance, this is going to be 2 to 3. Is that correct? So that's what you have. So now, from this now, 1 mole to 3 mole to 2 moles, if you calculate the total molar mass for this now, for 1 mole of this is going to be 2 times, you remember, 1 nitrogen is 14. 14 times 2 is going to be 28. This is going to be, for hydrogen, 2 times 1 times 3, that's 6. So this is going to be 6. This is 17 times 2, that's 34. So if you add it all together, so if you say 28 plus 6, that's 34. So the total mass will be the same on both sides. And that's what that law is trying to tell you. So it obeys what we call the law of conservation of mass. So your answer is B. So please, you're going to I've solved all these questions, but for you to practice as well, solve question 1, 2, and 3, and let's see what your answer is in the comment section. And in the next class, these were the formulas I applied and I gave you in the last class. Please solve your past questions and solve textbooks. I've been using LAMLAD, picking questions from LAMLAD. You can buy LAMLAD textbook and start solving all of those questions. So if there's anyone you cannot solve, just tell me the page number. Tell me the textbook. Tell me the number. Then I'll solve it for you while you are at home in that place. So I'll be explaining limiting and excess reagents in the next class. This is very important because it's not all the time you apply this formula that it will just work like that, because until you understand the concept of limiting and excess reagents. So I will explain that in the next class. Then I'll do a general overview. Then we'll solve all the questions we can solve. Then I'll now teach you the shortcut, and that will be the end of stoichiometry. And you shouldn't have problems again. So if you're here to subscribe, please subscribe to our YouTube channel, increase the number, encourage us to do more and more. We want to help you. We want to promote our education in Nigeria and do our best on our own part. So please, if you're here to subscribe, please subscribe, like our videos, make your comments, let us know the problems you're facing, let us know if the video is helpful, and if you find the video helpful, please help share with others that might be writing UTME, SSCE, one exam, A level, JUPEB, IGMB, and the likes. And God bless you. I'll see you around.